Let's continue by making the left engine assembly. Please pay attention to in which orientation I have my EDF laying on the table. The location of the EDF mounting brackets doesn't really matter, but what does matter is the exit location of the motor wires. We will take the EF2 former, which is the back EDF former, and that will be placed right there, such that it touches the EDF mounting bracket. I'm using some pencil to mark the location of that. Once we have the EF2 glued, we will take the EF1, which is the frontmost EDF mount. And here I have some 34mm spacers. Those are actually the ESC cutouts, so I'm using those to space out the EF1. Then let's just try to glue it quite aligned with the EF2. This piece is the ES4 engine skin piece. So I'm clearing all the slots, and I'm also transferring these reference lines for the servo mounts to the other side of the foam. Here we also have these marks which need to be transferred to the other side, because we need to make 2 store cuts on the back side of this piece. So that's what I'm doing here. Then we will just fold that guy up and glue it like that. Here I am removing the mid section of the paper for the folding. I'm also marking the paper reference lines to the other side to make the bending easier. The bending is a bit difficult because the back side needs to be constant radius arc, but the front side you need to bend more on the 2 edges. In the middle there isn't really much of a bend. Now we can test fit the EDF assembly to the engine skin 4. Here I need to take a small cutout for the EDF intake lip. And once the EDF fits well, then we can start gluing it. And here it is reasonable to glue it in multiple steps, so I'm taking 1 step at a time. Now this is the EF3. It's the backmost like thrust tube or EDF former. So we will work on that and make it fit to the back of the ES4. Then we also can glue that on. Now I'm basically just gluing the engine skin for 1 step at a time to the 3 EDF formers. Now we can begin with the nozzle assembly. So here I have the 3D printed nozzle mount. Then I will take the thrust vectoring nozzle, and these two pieces are the nozzle retainers. Now I'm taking some epoxy and I'm gluing the retainers on top of the nozzle mounts and the nozzles themselves. Note that I am not gluing the nozzle assembly to the engine assembly. I'm just gluing the nozzle mount and nozzle retainer to the thrust vectoring nozzle. We will glue the nozzle assembly to the engine assembly later on. The offset between the EF3 former and the nozzle mount, according to the CAD model, is 38 millimeters. Here we can see that my thrust tube is ever so slightly too long because the thrust vectoring nozzle cannot turn properly without hitting the tube. So I'm just cutting a slight amount of the thrust tube away. I actually had to make a couple of cuts to make it work properly. This is the ES3 engine skin piece. Again, we have to make two bends on this piece, so I'm marking the paper lines. And this piece is supposed to slide in the slots you can see on the wing. Here you can see that I really messed up the alignment of the ESC cutouts on the engine piece and the fuselage bottom. That's fixed in the plans, but for now I'm just hacking it together by cutting the fuselage. Now we will need to attach the ES3 piece to the engine assembly. So again I am gluing it a short section at a time, not even trying to do it all at once. Here I am centering all the servo motors. For the thrust vectoring servos, we also need to attach the linkage stoppers to the servo itself. This is the horizontal thrust vectoring servo mount. The servo gets screwed in with two 2mm self-tapping screws. Now we can make the proper cutout to the engine assembly and glue the horizontal thrust vectoring servo unit in place. This is the servo mount for the all-moving Stabilator. So again, the servo is attached with two of the M2 self-tapping screws. Then we need to make the small cutout for the servo. And once it fits, then we can just glue it on. This is the mount for the vertical thrust vectoring servo. Again, the servo just gets screwed on. Now the location of this doesn't really matter that much. I aligned it about 30 millimeters away of the back end of ES4. Then we will just make a proper cutout and glue the servo in place. I actually accidentally glued my left and right vertical thrust vectoring servo mount the wrong way around, so that meant my elevons and vertical thrust vectoring was going in opposite directions, and I had to manually change it in the Dreamflight code. So I recommend you glue these vertical thrust vectoring servo mounts the other way around, so left goes right and right goes left. For anyone who is not going for the all-moving Stabilator, but the conventional elevator system instead, here is how that's supposed to be done. There's this foam servo support piece, which is this one. So we take this one and we glue that onto the ES4, and then we glue the elevator / elevon servo into that. For the conventional elevator, you also have to cut out the two tabs on the ES4 piece. Now it is time to glue the engine assemblies to the main assembly. So the engine assembly is supposed to slot into the slots you can see there. And there is also this back tab and slot. I very much recommend not to hot glue this part, but use some 30-minute epoxy instead. You really don't want to mess up this part. You're going to hate your life if you mess this up. But I hate my life anyway, so doesn't matter. Okay, maybe I was just too lazy to use epoxy. Also don't forget to put glue on this gap in here. Now it's time to add the ESCs. So first we need to make some wire extensions. Instead of soldering, I'm using some crimping tools. Now I am taping all the ESC wires together because we need to fish these through the fuselage. Installing the ESC was by far the most annoying part of this build. The wires need to come out of this hole right here, and they need to go in right there. So I have this spring steel push rod which I've bent into a hook. I'm inserting it into the round hole, and as I have taped the ESC wires together, I can pull them through using the hook I just made. As I'm using only 60 amp ESCs, I figured I cut this heat shrink away to expose the aluminium heatsink. I don't know how much of a difference that makes, but I guess it's not going to be worse. Once the ESC fits, we can just use plenty of hot glue to glue it in place. I am not really proud of this ESC placement. It is unpractical and also a bit unclean, but it really was the only place I was able to fit the ESC in. Now this is the fuselage top piece. Those small slots are cutouts for the horizontal thrust vectoring servos. Now we will remove the paper of these like wing pieces, and we need to bend them. They will be the EDF/thrust tube covers. Here I'm basically just test fitting and making small adjustments as long as it nicely fits. Now let's take some strap piece of foam and cut 4 thin strips out of it. Then we will stack 2 of those on top of each other, on top of the thrust tube. This will be sort of a support piece for the EDF cover. And we will glue that on top of the thrust tube. I'm also reinforcing these seams with some hot glue. Now once everything fits well, we can glue the fuselage top piece on. I'm first gluing the frontal section and I'm leaving the back section, as you can see. Then I am taking some random piece of foam and I will glue it as a support in between. Then we can glue these EDF covers on. We will glue them on one by one. Here you can see me gluing first the front one and then the back. In hindsight, I recommend doing it the other way around. First the back one, then the front one, as the back one is better supported with the EF3 piece. It is easier that way. This piece is the fan cover piece. This piece is the ES5 piece. It's the last engine skin piece. For the thrust vectoring nozzles, you have to make this wide bevel on the back edge. And as always, we will use some rod tube to bend the piece. Now, installing this piece is a bit difficult. So the easiest method again is to glue it one section at a time. And also here we need to make a cutout on the paper for the Stabilator servo mount. Here I'm basically fitting and modifying it as many times as required to make it fit well. And once it fits, we can glue the make the first glue seam. It is also important to note that these thrust vectoring nozzles need to be quite well attached to the rest of the engine assembly, because when we vector the thrust, especially on full throttle, there are actually quite some forces acting on the nozzle. So just make sure the nozzle is well attached to the ES5, and also the ES5 is well attached to the rest of the engine assembly. If you use the static nozzle instead of thrust vectoring one, this is how it's assembled. And you also use the longer thrust tube. Here I am installing the static canards, and this long piece is the WS2. The way I am installing these is that I have the canard mounted but not glued. Then I am gluing the WS2, and only then I am gluing the canard only on the outer edge, as you can see soon. This is because this way, if I somehow break the canard, I can quite easily replace it with a new one. At this point I noticed that there is actually quite a bit of flex in the fuselage nose, which is not a great thing because there are a lot of batteries, which is a lot of mass introducing forces when pulling G's. So I came up with this quite easy fix. So we cut a slot in here and we insert a strip of foam board. This FF3 former is kind of a weak spot for the fuselage, but by attaching this one strip of foam board, it actually gets quite a bit more rigid. This piece is the FS6A. Now we can cut the opening for the top hatch. I'm just using the hatch itself as a reference and cutting around it. I'm first cutting undersized and then I'm going to enlarge the hole as needed. Then we can use some epoxy to glue the hatch on. Now I'm soldering the extension wires for all the batteries. Since I am using 4 small drone batteries, I have 2 batteries attached parallel to one ESC, and then I also have bridged those sets together in parallel. This piece is the FS5A skin piece. So we will prepare that by opening the store struts, and also we will bend the part in the middle, and that's where it's supposed to be mounted. I had to trim these additional support strips a little bit. Installing these top skin pieces is a bit of a trial and error process, so you need to just make test fits and make adjustments as long as needed. The way I'm doing this is I am first putting glue in the store cuts. I'm actually not gluing the piece on the plane yet. I'm just gluing the store cuts shut so that the piece holds its form. Then I'm doing the same thing on the other side. And once both of the sides are glued so the piece hold its form, then it is actually a lot easier to glue the piece on the plane. Then I am fitting the other side, and as you can see, there is a little bit of material that needs to be removed. Just be patient and make test fits and adjustments as long as needed, and eventually it will fit well. This small piece is the FS4B and the larger one is the FS4A. The FS4A looks a lot different than what it looks in the plans. That's because I have changed the plans since. So don't let that fool you. Anyways, the FS4B is attached to the FS4A. Then we can remove these paper pieces, after which we will bend the front section of the combined piece like this. And then this part will fit over the nose like that. And this is how the updated FS4 skin piece looks like. Here I am preparing the updated FS4 piece. As you can see, the previous FS4 is still, the front part of it is still attached to my plane, because I made the modification only after I had glued the piece in. So that's why you see me cutting just these side pieces. You will need to attach the whole FS4 piece at once. Unfortunately, it is a bit unclear, but that's how it is, because I made some modifications after realizing that the previous design wasn't really optimal. Also, I'm using here the same strategy of first gluing these door cuts to make the piece hold its shape, and after that I will glue the whole piece onto the airplane. Another thing is that you can see I have already made the 3 nose cones, so this video at this point isn't really in chronological order, unfortunately. But here I'm showing how to make the nose cone. So these 3 cone pieces are the FS1, 2 and 3. Now we will begin by gluing a small section of the FS3 to the nose. Then we can test fit the piece around the nose, and it turned out I had to trim a little bit of foam on the end. So I did that, and then I just glued it on the rest of the way. Then I also did the exact same process on the FS2. And now this is the FS1, the sharp cone piece. This one is quite a sharp bend, so you need quite a bit of patience to just work the foam as long as it needs. So once that's formed into the shape, then we can just glue it on. This piece is the FS5B and FS6B. These are the bottom fuselage skin pieces. And this piece is the FS7. In the plans there is included the 3D printed GoPro mount, and that piece is supposed to be installed within the FS7 piece like shown in here. I actually intended to do that, but then I forgot. Now I will be preparing the all moving stabilator part. So we will remove all this excess foam within the stabilator. Then we will make some chamfers on the inner edge, and then we can fold the stabilator together. This is the 3D printed stabilator hinge, and just make sure you take the correct one. As you can see, there is an angle to make all the linkages perpendicular to each other. So make sure you take the right one to the right stabilator. Here I am cutting just a small relief for the screw head, so it turns properly. Then I am gluing the stabilator hinge to the stabilator. Then I am adding some grease to the screw. And then just make sure the screw is actually rotating properly inside the 3D printed hinge, so there is no unnecessary friction. And once everything is fine, then we can glue the stabilator shut. And here I'm using excessive amount of force to really press the stabilator together. Here I am preparing the vertical stabilizer. Again, we remove these unnecessary papers and we chamfer the edge on both sides. Then I'm just slowly working the foam instead of bending it once, so I don't break anything. And then again we just glue it and press it together. Use a lot of force in here. Then this is the tail gap piece. This is both closing the gap, but it's also supporting the vertical stabilizer. Then the vertical stabilizer just slides on like that. Then I will also add some glue to the top surface. So that's basically how it's supposed to look at this point. Now I will be making the canopy. This piece is the canopy base, so we will add some bevels to the edges. This small piece is the CF1 Canopy former one. This is the CS-3. It is the main Canopy skin piece. There's also the 3D printed Canopy version that is a lot easier to make and probably also looks better. But I'm making the foam one just for demonstration purposes. And I think it's also a couple of grams lighter. Now I will be preparing the CS1 and CS2 pieces. These are the first and second Canopy pieces, Canopy skin pieces. So both of those need to be bent. Then that's again the CF1 Canopy former that will be glued in between the reference lines. Then those end formers will be bent up like that. And now I am test fitting the Canopy skin pieces and just marking the center line. I am really just eyeballing it here. I'm not measuring. There is quite a bit of margin of error, so as you can see now when I'm gluing the sides, there is actually quite a bit of foam that needs to be cut off the edge. Then we do the exact same process with the CS2 skin piece. First glue on the front and back ends, and only after that glue the sides, which I didn't show. I have also installed the CF2 canopy former on top of the canopy, as you can see right there. And on top of that will be installed the CS3 canopy skin piece, or the 3D printed equivalent one if you choose to do so. Sorry, this build video is not really in chronological order at this point of time. That's because I actually redesigned the whole canopy when I had already made the previous one, so it kind of messed up the build video order. Anyways, the way I am gluing this piece, which is a bit of a complicated piece, I am basically just gluing one section at a time. I began on the middle and then one section at a time. It's actually not that bad. Once the canopy is done, that's how it's supposed to look like, and then we just pray that it fits the airplane. In my case, it did not fit perfectly, so I had to trim quite a bit of foam board on the fuselage side. Also here on the canopy side, had to take some foam away. In the end, I still had some gap between the canopy and the fuselage, so I didn't really get it perfect, but it was close enough. This is the canopy lock front B. So the B lock parts attached to the canopy and the A parts attached to the fuselage. Here I'm using the canopy itself. I'm stabbing some marks to the nose. Then I'm attaching the A part of the lock with some tape. And then I'm using some epoxy to glue the A part of the lock to the fuselage nose. Also that's the canopy lock B back part that attaches to the canopy back. I will also use epoxy to glue that on the canopy. Then that's the back A part of the locks. That will also be glued with epoxy. Then this is the lock latch that will be screwed on using one 2mm self-tapping screw. Here I'm using a ball and hex key to screw the all-moving stabilator to the stabilator mount. But then I actually switched to a conventional hex key because the ball end one was some weird non-metric unit, so it didn't really fit the screw head. Now I'm bending some 1.5mm spring steel push rod and cut that to the length, and that will be the stabilator push rod. This is the control horn for the thrust vector nozzles. I'm using these 2mm ball linkages. So those ball linkages will be screwed on the control horn, and the control horn will be glued to the thrust vector nozzle. Then I am using some M2 threaded rod as push rods for the thrust vector nozzles. So I'm screwing these M2 ball hinge things onto the push rods and inserting the push rod to the linked stopper of the servo. Now it's also very important to use thread lock on these connections. You will have a bad day if these come loose midair. Then these are the intake grills or cheat inlets. I am going to be using 4 of them, 2 on the front and 2 on the back side. So that's the back side one and the front ones. This is the final part of the build. It's the launch tab. If you are launching the plane yourself as the pilot, then it's recommended to install this. It makes it a lot easier to grab on the plane and launch it with one hand. So that gets glued onto the belly of the airplane, and then there are these 3D printed support parts that makes the launch tab a bit more rigid. And that is it. That was my last piece of build footage I've got. So the airplane should be pretty much complete by now. Now the only thing left to do is to configure the radio, whichever way you decide to do that. I am using the Dreamflight software on the TNC 4.0 microcontroller. You can find my version of the code in the set of plans, and I will have also a link to the original Dreamflight open source project in the description. So I recommend checking that out if you are interested in the flight stabilization system. It also has a very nice documentation. Here you can see the active stabilization. Other than that, I think I have now given the most important information on how to build this model, and you should be able to recreate this model from the set of plans and using this build guide. If you are attempting this build, then good luck. Just remember, it is a challenging model to build, and patience very much is the key to get a successful model that flies well. But anyways, that is all I've got for now. So thanks for sticking around and goodbye.